Okay, so where we left off the other day was talking about target selection theory and fundamentally the idea that the bad guys are going to try to do damage in a way that gets them the most money they can. So in terms of anything that will attack more machines, or attacks that have a higher probability of success, or attacks that give more money per successful attack, right? So the net thing of those, that's what the bad guys are going after. Okay, now how this applies to actual history. Fundamentally, the graph looks like this. So if we're going to draw out a plot of how things went in terms of history, what we have is basically this. Okay, so here's going to be time, and we'll say, oh shit, that's big. Okay. Come on, Paint, do your thing. There's a lot of lag here for some reason. There we go. All right, fine. Okay, let's make that 18. Okay, so that's time. And we'll say here is, I don't know, 1995, and here's 2005, and over here, 2015. Okay, something like that. Let's move you a little bit so it looks a little closer. And we're going to move you a little bit. Drag you down. Okay. Then over here, we're going to do usage and threat prevalence. Okay. So 1995 or so, applets start to be adopted. So we'll use red for the applets. They start coming around. They get big. Shit, I meant to... Man, nothing's working today. All right. Okay. So usage got big, big, big around 2000. Then suddenly, pretty abruptly, fell off a cliff. Okay? So this one here, this is usage. Security problems basically followed a similar pattern, but lagged. So I'm going to do, let's do that with a brush. Let's pick a fun brush. Okay? Here's our security threats. Basically, they taper off. Okay? So, attacks. Now, 2005 is kind of early, like 2003-ish is maybe the peak use of applets. But at that time, there's all sorts of attacks out on them as well. And so people start thinking, wow, applets, number one, they don't look good. They're really vulnerable to all these security attacks. So what happens? Well, people start developing Macromedia Flash, similar products, right? So those start coming on, very quickly become popular. And then again, kind of fall off a cliff around 2015, 2016. So what's happening in this kind of window, similar thing again. We'll show you, let's use this one. We can get a better brush than that. Let's use you, I guess. Okay, what happens is, again, no security threats for a while, but eventually, actually, even more than applets ever had, lots more off the chart. Initially, few attacks, eventually, loads. Okay? But the problem is around 2005, when Flash is becoming popular, people look, hey, Flash Player. There's nothing happening with Flash Player. Flash Player's safe. And like, no, it's not really safe. It's just, it hasn't caught on enough and hasn't been around long enough for the bad guys to start devising attacks against it. Okay, meanwhile, 2005, people look at applets and say, oh shit, applets, very vulnerable. But eventually, the numbers got even worse for the for Flash Player. So if we look, we can do a quick Google search here. Okay, so I can do Flash Player vulnerabilities. Okay, we'll get to the, where's my CV details. This, Adobe Flash Player, 1,078 vulnerabilities, many of them red. Red is like an oh shit category of security threat. Okay, lots and lots and lots, like 20 pages like that of security vulnerabilities. So lots of problems. Anyway, but initially they didn't look like they were too bad. So, how this target selection theory, how it applied to actual history, when applets were popular, they were attacked. As plugins replaced applets, they had their turn to be attacked. And as those vulnerabilities got patched, right, and they basically, number one, there weren't so many active vulnerabilities still in Flash Player, and number two, new versions of HTML made Flash Player somewhat obsolete, then there's nothing to do there. So they start going after phishing attacks, right? That's basically the rise of phishing attacks, because all of these vulnerabilities in Flash Player and other things that were very popular targets, suddenly they're not so viable. So any technology that gets used across platforms is always a big, fat, juicy target. So Java applets, remember Java's a universal language, source code can run on any machine. Java's platform independent, so if you can attack one Java vulnerability, you target all those machines. Likewise, plugins that are compatible with multiple operating systems are very popular, those ones, big targets. For example, when Flash Player is running on both Apple's and Windows machines, then you can basically target everything with that. And of course, phishing, because email applications tend to work the same way, right? Regardless of what email application you're using, yeah, it's going to pretty much be about the same. If you fall for a phishing application on one email app, you'll fall for it on another. Okay. So, scripting is the alternative to plugins. Okay, so remember with plugins with videos, basically you'd have a separate standalone application that would play the video, even if it played it within the web page. Excuse me. You have a script. A script is a small program basically that connects to the video source and downloads the streams of data, right? The image frames and the audio stream. It downloads that and it displays it in the window. So this script then gets embedded in an HTML tag, so it runs when the page is loaded in the browser. So in general, scripting has fewer security issues than plugins, right? Reason number one, you're not actually installing a separate application and giving it permission to access data inside your machine, right? It's something that runs in the web page and is going to pull that data and is hopefully configured to only pull data from some external source and then display it, not actually access much stuff on your machine. In particular, video should only display image frames, so its actions can be constrained by the browser, right? The browser can say, this is a video, all you're going to do with that script is play that video. It can't actually access anything else. And it's pretty easy for automated security tools to say, all that this video script should be able to do is pull data from some external source, don't really care what it is, and play it. And you just don't, if you say, this script wants to access other stuff on my machine, we just say, no, you can't do that. Okay? In particular, relying on standard formats through APIs makes it very easy to detect malicious code. So if you have an API that basically says, number one, what's the file that's the source of the video? Number two, what's the format of the video? Number three, how long is the video? What's the frame rate? Stuff like that. You can say, I know exactly what these parameters are going to be. If something is outside of that, then hey, it's probably malware, probably not an actual video, and I'm just going to block it. Okay? That's one of the advantages of these standard API formats. If something isn't a video, you're not really going to be able to fit it into that video format. Okay? All right. Now, there's two kinds of scripting, client-side and server-side. So client-side scripts, basically all the work happens on the client machine. Go figure. So if you are the client, right, if you're going to YouTube to look at stuff and there's a client-side script, the script is actually running on your machine. So JavaScript is a client-side script. So you have a script embedded in an HTML tag. When the page is loaded, the page includes the script and the script runs. Okay? Key characteristics, JavaScript tends to be relatively short and simple programs. There's a reason why the games you play in your web browser, stuff like Candy Crush and Angry Birds and whatever else people are doing these days, they're pretty quick and easy as games go, right? It's not going to be hardcore stuff, you know, like your latest Call of Duty or whatever. Because you don't want to have the page load super slow. So the graphics are going to be relatively simple and easy. There's not going to be super sophisticated artificial intelligence in the games, all stuff like that. Number two, JavaScript is good to keep the games running fast because everything you're doing in the game doesn't require some kind of request response cycle from the server, right? So again, we play Angry Birds, we pull that slingshot back. Those pixel changes are happening totally on my machine, right? It's not that I have to call the server and say, okay, my instruction is I'm moving the mouse 1 pixel, call the server, get the new image of what the frame should be, display that frame. It would be super sludgy and slow if it tried to do it like that. You really want to have these kind of apps just running on your machine and only getting data in batches for like new levels. Okay? The other thing, the reason why the game providers like these is basically they don't generate much traffic on the server side, right? You're playing Angry Birds on your machine. All you got to do is you connect to the server, get permission to download a new batch of levels. You do that, then the server doesn't have to worry about you again until the next time you download a new batch of levels. Okay? Okay. So let me give you an example. This is where we get to this JavaScript. I'm going to do a basic one. Oh, we already did this. Did we do the date and time one already? No? Okay. All right. There's another one with the light bulb, but I have to install some stuff on there. Okay. So this is a little bit of JavaScript here. So over here, this is our oh shit, you can't see it for some reason. That's wacky. There, now you can see it? No, okay. I don't know what happened there. So over here on the left, this is all the HTML source code, right? This is what's displaying on the other panel on the right. So we see an H2, we see a header tag, right, for my first JavaScript, that's over here. We see a button tag, that's here. The button's internal text is click me to display date and time. That's what we see written on the button. Now, this is the onClick attribute. The onClick attribute of an HTML tag specifies this is what happens when somebody clicks on the button. And what happens is we access this. We access this document.getElementById demo. So in this document, in this HTML page, we find the element that's been labeled demo, which is, hey, down here, this paragraph tag has an ID attribute, and we set its inner HTML, right, the space between the opening and closing tag, to display the results of this date function. So date is a function that just pulls the current time from your machine and says, okay, this is what time I think it is. And it's going to display that inside this paragraph tag. Okay? So when I press the button, this active thing is going to happen. Okay? Because the date and time could be different whenever I press the button. So it's active in that sense. So press it. Boom. Aha. There it is. Do I press it again? I press again, some wacky. Ooh, shit. Disney, what the fuck? It should not do that. Huh. That's how W3 Schools is making money. Okay. Anyway, so you see every time I click it, it does update. I don't know why I got a Disney click for that, but you see? Active content, very simple JavaScript, client-side script. Questions about that? Client-side scripting? You guys, some of you guys have done JavaScript, right, this week? Yes? No? No one went to lab this week? I think this week's lab is JavaScript, right? Yeah, okay. All right. Okay. So, next thing, server-side scripting. So, if a client-side script runs on the client machine, then a server-side script must certainly run on the server machine. Okay, so script exists and runs remotely on a server. And the most common one maybe you see for that is PHP. So what PHP does, I'll walk through that. Okay, so normal operation of life, right? So this is the client, which is you. And we'll say this is a server. And let's say it's Yahoo Finance. And you're asking them for stock prices, okay? So let's draw the boxes. You send Yahoo Finance request for stock prices, right? Historical stock price data. Okay? What happens? Yahoo Finance doesn't have a page already constructed with your unique range of stock and dates, okay? They just don't. They don't have a unique page already pre-set up for every possible set of stocks and data that you might want to get. So they have to construct it after receiving your request. Okay? That's what PHP does. So essentially, in a PHP, there's a web page that contains a PHP script. And that script will specify typically the database query that runs. In this case, the stock and date range to pull the data. Okay? So, inside the page is going to look something. We'll do it over here. Basically, there's going to be some HTML. Somewhere in there, there's going to be a PHP script. Okay, so we'll just call that PHP, and then get data query, get data for query. That's basically what it's going to do. And then within that spot on the page, once it's called the database system, gotten that data, it puts it there in some kind of format, right? Some kind of HTML format. So after retrieving the query results, the page will be constructed with the HTML to display the results. Okay? Client never sees the PHP script. Okay, so when the client calls Yahoo Finance and says, give me, stock prices for Amazon from January 1st, 2000 to December 31st, 2002, in that page, there's a PHP script. And that's going to be written to say, get the stock, get the date range. That generates a call to a database, a query. The query results come back, and somehow the PHP script is going to be configured to say, grab this data and display it in a table, right? So one row for each date, different columns for different attributes like stock price, starting price, ending price, day change, percent change, stuff like that, dividends, whatever. That's all going to be displayed in an HTML table. And then that page that has the script, being converted into an HTML batch of query results, that's what the user actually gets. And we can draw that back. All right, so sends back a constructed page with query results. Okay, that's how PHP works. And it's this neat thing because, again, the client machine never actually sees the PHP script, only sees the result that the PHP script produces. So, I'm going to talk about that. So, when the page gets retrieved from the server, PHP script executes, its results are sent as HTML. User sees only HTML, not any PHP code. Okay? So, key characteristics, actual script code is hidden from all users, which helps with security. Right? The outsiders, they can't look at and see what the script exactly does. Makes it a little harder to attack it. Number two, scripts load faster and can be more complex. Reason why is they're back on the organization's machine. So if it's a complicated, script, they can somehow optimize their system to run that particular script faster. If it were running on the client machine, well, you'd have to be prepared for it to run on any kind of hardware. Maybe it's not going to run so well on some. Okay? And last, easier to securely integrate with back-end databases. Reason is, you've already specified the query in a certain format. It's easier, your server machine is already directly connected to a database machine, so it's going to be pretty secure. All that is inside your organizational boundary. You don't really have to worry about somebody sending in some malformed query that could do something bad because it's already going to run through a server machine that says, this is an actual legit query, I'm going to forward it. If they can't construct it into a legitimate SQL operation, they probably won't pass it on along at all. So, okay. Next thing, HTML5. So we remember HTML, primary language for writing web pages. As you might expect, even if you didn't know, HTML has gone through a bunch of versions since it was incepted. Most recent version, HTML5, released in 2014. The previous one, HTML 4.0, was actually released in the late 90s. So there was a long gap where not much happened with the standard. You can still find pages that use HTML 4.0, right? If it's some old page, it doesn't have a lot of dynamic content, there's no really compelling reason to upgrade. Main features of HTML5 is providing functions, especially for things like video play, that make plugins unnecessary and provide better security. Okay, so we talked about all the security problems with plugins. Well, with HTML5, you no longer need a separate application with your browser to do that. The HTML language is already constructed now to handle video playing. Didn't used to be, but with HTML5 it is. So if your browser can display HTML5, you don't have to worry about having some extra application tacked on, right? And hopefully your browser is trustworthy. Okay. So, how active content gets displayed, right? So again, web page is going to reserve some component space for the application to run, right? There's going to be some portion of the page where the video streaming is going to happen. With HTML4 and before, you had a couple options. Number one, you could have an inline frame, what's called an iframe tag, that delegates content delivery to some third party, right? So iframes are basically, in a sense, they pull data from some outside source. So one of the places where you commonly see iframes, if you're on a page that's not a Facebook page, but it still has, you know, a Facebook like option on it, that's in an iframe, right? If you click on that, Facebook is going to manage that, that like, not the actual site itself. Option number two, right? You have a plugin. You have a plugin machine, plugin application on your machine, and that handles all the active content display. Now with HTML5, you can of course still do those first two. They're still out there, but the HTML language itself has a mechanism for acting as a plugin. Basically, your browser can be the plugin now, which means there is no plugin. And video data in any number of standard formats can be correctly interpreted by the web browser itself. You no longer need some outside application to do that. Excuse me. So, interfacing. Suppose you have two applications that need to communicate with each other. For example, right, your YouTube video player and your web browser. Those are two separate applications. They need to work together so that you can actually see the video. So the applications need some kind of common language, some kind of interpretation process in order to understand each other. And that's where the interfaces come in, right? Interfaces mean, number one, inputs have to conform to some standard format or else the receiving application is going to reject it. So in terms of video, that means, you know, the video has a standard format. I mean, there could be a bunch of different ones like WMVs and MPEGs and different formats of MPEGs, whatever other video formats there are. As long as it's one of those standard ones, then the browser can recognize, oh, yeah, this is a standard video format. I'm used to this one. I'm going to display it. Application outputs, of course, will also be displayed in a standard format, right? So you'll have the frame size, you'll have the number of frames per second, you'll have, you know, the video quality and the audio quality, all that, standard format. So, be able to know what's gonna be there. Now, why standard interfaces are very important. So, big thing, standardization lets your system handle many different software and hardware types. So, start off, let's say it's in 1995 and you're the first person to make some kind of interface between a video player and a web browser. You're the first guy to do this, okay? So there's only one web browser, only one video player application, which is not far from the truth for 1995. So since there's only one of each, there can only be one unique browser and video pairing, right? There's only one of each, so that's all there is. So you do need an interface because video data is stored in some specific format that has to be played by the browser. You still need to translate between the two, but you can custom design it. You could say, well, I know this is the browser that it's going to run on, and the browser says, well, I know what the one video format is going to be. I can very tightly couple those two applications together. I can optimize the performance for both applications, right? So whatever the, that video format is going to be, I can design my browser to display that format as well as it possibly can. But over time, right, 10 years later, many browsers, many different video applications, many different video formats. So there's a lot of different browser and video application pairings. So if I'm going to customize that, I need to require many different interfaces, right? Basically, the number of browsers times the number of video formats. It's going to be a lot. I'm going to have, I'm just going to spend my whole life defining interfaces. So instead, much cheaper and faster to simply enforce one standard, right? Or a small set of standards. We say, you know what? If you're a web browser, this is the standard way that web browsers are going to display video data. If you're a video, you're going to use this standard format to do it. Now, as it happens, there's some latitude in there. There's a few different formats, and the browsers can accept them because different types of formats, right, they're going to be used on different machines. But, yeah, we try to limit it. All right. So, again, APIs are the technology used to enforce standard communication models between applications. So, conceptual example, video is a set of images with a specified delay between the frames, right? So if you're showing 30 frames per second, the delay between is 1/30th of a second before you get the next frame. So video content could be delivered as either single frames or clusters of sequential frames, right? So there's going to be some stream of frames that you're getting. Each packet for the video, right? Each amount of data, depending on how you're sending it, could be compressed, could be individually, whatever. You're going to get some kind of frame stuff. And each delivery, again, might be uncompressed or compressed in one of several standard formats. So, designing the API to deal with that, number one, you could accept single or bundled frames, right? So we talked about video compression a little bit. For example, if you have a frame that just repeats, it just sits with the same image for a full second, there's no reason to send those 30 frames separately, right? We send one frame first, and then send some kind of note that says, and then repeat this 29 more times, right? And that'll get us our 30 frames in a second. Number two, widely used compression technologies, right? You're not going to accept everything that's out there, right? If somebody's just designed a brand new compression technology, even if it's great, it's going to take a while to include that in all the various browser formats out there, right? And all the APIs, because it's brand new. But if it is a really good compression technology, then yeah, whenever they update this, they'll probably include that new one. And in the end, what you'll have, most video formats will be readable, right? It'll be viewable, but maybe not all. Okay, so the ones that are popular, that are widely used, yeah, it makes sense that you would want your browsers to be able to play them. If there's some really obscure video format that's only being used by, a very small group of odd people, yeah, maybe you're not worried about that one, right? But if it catches on and becomes popular, then you say, wow, yeah, this is something we ought to include because it's suddenly a substantial fraction of content. Excuse me. Okay. So, questions on any of this? How's everybody doing? All right? No questions? This is all making so much sense? What's an API? Okay. Application programming interface, I would also accept that. Okay. All right. Well, all right, so YouTube evolution, practical application. So way back when, right, up to like 2014 or so, YouTube relied on plugins, right? Because why? Because it had to. Your standard web browsers, they didn't have video play capability. So one thing that was a neat trick, you could often save the video directly through the web page by right-clicking on it, right? So YouTube would display the video. If you wanted to just save it, you didn't want to keep coming back to YouTube every day to watch it. You say, well, I'm just going to save it on my machine. Yeah, a lot of times you could save them by right-clicking. Other video sites too. Switch to HTML5 though, not only improved security, but also made it harder for users to avoid ads. So one of the things, when you're playing these videos, the video data has to get stored somewhere, right? We talked about buffering. Eventually you have the whole video buffered, right? If you sit there and you watch YouTube for a little while, it has the whole thing buffered. Well, that has to be stored somewhere on your machine, right? Stored in some kind of temporary browser files while you're watching it. So yeah, it's still going to get stored on your machine. With HTML5, sure, your video content still gets delivered to you, still gets stored in your web browser, but it's harder to extract and view outside the browser. You can't just click on it and save it as a separate file because the API is not configured to allow that. Now, if you're really motivated, yeah, there's software out there you can do it. You can do video capture for segments of your screen, sure. But it is harder for viewers to avoid repeatedly seeing the video, thus harder for viewers to avoid seeing ads. That's really what YouTube wants. They don't want you, if there's a video that's getting 6 billion views, they don't want people to just show up once, see it, like it, download it, and never come back to YouTube to watch it again, right? They want people to come back those 6 billion times and see 6 billion ads so that YouTube gets some money, right? Okay, so it's had that secondary bonus. YouTube is probably pretty happy about that. Just saying. Okay. And that's it. That's the end of this YouTube stuff. Not all you. We have another thing. So Since we're a little early, I'm going to take a couple minutes. Let me ask, any questions? Nothing? Why is the sky blue? Why are clouds fluffy? Nothing? Okay.